on the countryside in Germany. So anyhow, it's nice and calm, and we're going to speak about building dynamic internal developer platforms with reference architectures for Azure-focused setups. We've looked at GCP setups. We've looked at Amazon setups. We are now looking at Azure setups. We're exploring OpenShift setups. We'll look in more depth in multi-cloud. And I'm looking a bit, especially in the currently from a financial services perspective, we are getting lots of implementations on the Azure side. And I want to explore this in a little more detail. And I would say we jump right in, and so that you can also ask your question. We are going to first look a little bit at how those reference architectures were developed. They were developed in tandem with the platform team at McKinsey, or to be entirely precise, those guys actually wrote them, but we designed them together, and some of them were shown at PlatformCon last week by the guys actually doing them. So I'm stealing a little bit of their thunder, but it was the second most viewed talk at PlatformCon, so I guess they had their thunder. We're then looking at the problems we aim to solve, the design principles that were used while designing them, the design of the system itself, and then I want to look at some golden paths we can design with them. All right. Why are we doing this? Well, because I think there was a lot of buzzwords when we started looking, working, at more scale in platform engineering. I've been doing platform engineering for a good amount of time now, but there were just not enough examples of actual platforms that were built in order to, be representative of how could standard patterns look. There is no standard pattern, right? So it will remain the fact that the platform for a startup in New Delhi will look different to the startup to the platform of a financial services company in, let's say, New York. But there are common patterns that we can use and actually see over and over again. And the reference architecture it has been developed, as I said, by us and McKinsey, and we're all seeing just. I mean, I think what the unique situation we're in the last years, we've just seen a lot of setups. We've rolled out a lot of really large scale platforms, and it was incredibly interesting to. McKinsey has a group of, I think, 250 platform people that do large scale rollouts, and I have thoroughly enjoyed working with them over the years. And then, just a couple of really interesting insights to see, do we have like a selection bias? And I'm sure we have, like if you're looking at this, those are platforms designed for setups from 100 developers onwards, maybe 50 developers onwards. But everything I say, you should really take with a grain of salt if you are less than 50 developers, because I think those system designs are just overkill for you. My recommendation remains for the small cases: use Helm charts, use raw Terraform, use Heroku. I keep saying that. Now, what are the problems that we want to solve? As usual in platforming, right? We want to, in the end, it comes down to standardization. But a lot of the teams we look at, they're in their second, third, fourth, fifth wave of cloud native, and they're starting to realize that the setup that they have right now leads to overwhelmed developers and overwhelmed operation teams. You're observing long lead time, things like ticket ops, high cost of maintenance, and you hear people saying, "Oh, it's not complex to have Helm charts or Terraform," and that's correct, right? But the single Helm chart isn't complicated at all. But hundreds of Helm charts, hundreds of Terraform, hundreds of whatever CDKs get complex, right? And so that's the thing. That means you're wasting time, and in the end, you're not shipping innovation fast enough. And especially in times like this is not super helpful for the business side of things. And what we want to get to is low lead times, high degree of standardization. I can't stress enough how important that is. It really all comes down to standardization. We want to have separation of concerns, and we want to have a high degree of self-service. And that's only possible, in our opinion at least, if you treat your platform as a product, if you build these IDPs. Now, I think with all of those things, it comes down to getting the fundamentals right. Honestly, scrap what you're seeing here. I think the most important thing, and this will sound incredibly stupid, but the most important thing is to get role-based access control the right way. High degree or strict approach to role-based access control, you'll get high standardization. That means not everybody can change all the resources. In low degree of RBAC, more free floating, more freestyle, you get a low degree of standardization. And I'm not saying the one is better than the other. You just need to figure out from an organizational perspective what feels better for you. I really believe in that idea of dynamic configuration management. And if you've listened to other talks that I've given, then you know that this is the key thing that I want to drive home. That idea, you should treat every single release like day zero. You shouldn't think about scaffolding only the first time you create a service. You should create app and infrastructure configurations dynamically with every single deployment. And when you do that the right way, then you drive standardization by design, one of my key design principles. And once you have that, all of the rest will follow. You'll have a high degree of self-service, you have low ticket ops, you have less config files, you can build golden paths, you have low cognitive load, and then your life will be great and you'll slash your lead time. That's sort of my simplified world view, if you want to put it like this. Okay, so what's the reference architecture? It's more or less a standard pattern that you can use, and we're using example tools. You know, whatever. You can use any CI, you can use any registry, you can use any platform orchestrator. You know, this doesn't matter. We're giving you, you know, from what we perceive is a good systemic design. We have them here as visual flow diagrams. We have them packaged as code, and that means you can reuse them. We're open sourcing them. McKinsey's open sourcing them, or we are open sourcing them. That is not through legal yet, so otherwise it would be open sourced already. We're releasing all of that. I'm using them already. If you wanna see them, if you wanna use them, you know, you can reach out, and we can you know, give you access. We can just not, because of the licensing thing, put that out in the open just yet. They're white papers, they're shipping tutorials, but that doesn't need to bother us for now. Okay, so what are the design principles that we have actually applied when building them? And there are 4 key design principles. Number 1, golden paths over cages. That for me means we do not want to get into the age of empire, no, the age of, you know, throw over the fenced operations again, where you had people building stuff and then shipping over to ops, and developers were completely restricted and absolutely tightly bound to what the platform team supplied to them. We do not want to get into those situations again. So we want to offer golden paths, or as Netflix calls it, paved roads, but we don't want to be too restrictive. We want to allow people to go off the golden path should they want that, should that be necessary, and should the security posture allow that. Second, I am, as I said, always opting for dynamic over static configuration management, dynamically create configs. And if you do that, we want to have that standardization by design. What that means from a architectural perspective, using the platform should increase the degree of standardization or keep it constant. And that's a little bit of a noble dream, right? Will you be able to get that end to end? I don't know, you know, if you know, where you work, you create toil, and there will always be some sort of drift, but you want to keep that to a minimum. And then I believe in code first, right? I think the platform should be code. I think the interface for the developer should be code first. Should be you should have your single source of truth as code. I think it doesn't. I mean, that by no means means that you can't also have a user interface and a portal. Makes total sense for a couple of user groups, but I'm just saying you shouldn't force users to use something specific. Those interfaces should be interchangeable, and I believe in the end you need to meet the user where the user is, and honestly the user is in Visual Studio Code. And if you want to drive a high degree of adoption in the developer population, you probably want to optimize for a code first approach. That's my philosophy. That's what I've seen work best. Yeah, so which is why we're putting this here. All right, here we go. That's an internal developer platform based on Azure. And some of you will look at this and say, oh my God, why would you use Azure Monitor? And I get that, fair comment. We can shift these things around. You could use different tools. This is really to help you or orientate yourself. So in all of those designs, we have 5 different what we call planes. Number 1 is the developer control plane. And the developer control plane is the primary interaction method for the different personas with the platform. Now, there are a number of personas, right? You have your users, the end users, the developers, you have the platform engineers, maybe the infrastructure people, you have security people, you have product managers looking at stuff. There are different personas. The core personas in the end, the developers and the platform engineers. And we have obviously our IDE. We have maybe a service catalog for scaffolding, to observe stuff, or service catalog functionality. And in this case, we're using Backstage, which is, honestly, in 8 of 10 cases, I'm walking and I'm seeing Backstage. It's an open source project by Spotify. There are others that are also pretty cool. I'm a bit, for instance, there is Compass by Atlassian. If you're in the Jira world, definitely something that I would consider as well. A couple of newcomers, Port, Cortex, and they're worth a look at as well. And I'm going to look at what interface for what situation, and then you have the
Yeah, I cannot hear Kaspar as well. Let me check in with him. Yeah, he'll rejoin, I guess. Hi, Kraus. Do you have any questions so far? I'm looking forward to those as last time. Not today. Kaspar? Still no sound and no audio.
All right, now we're back. I'm sorry, there's a little bit of entertainment for you, but this thing decided to shut down. But now we're live again. Okay, cool. Let's continue right where we stopped. So we have SCORE, and SCORE is, as I discussed, a workload specification. A workload specification is a way for developers. If you want to dynamically create configurations, then you need to have a way to actually, for the developers to describe in general terms their architecture, if you want. SCORE as a workload specification is a way to describe the relationship of workloads and dependent resources in an environment agnostic way. I'm going to show you an example in just a second. Disclaimer, it's an open source project. That's not the disclaimer. The disclaimer is I have worked on it, so I'm a little biased. but I think that's okay because it's free and it will always be. There are others, you know, that are, but they're more Kubernetes centered. Acorn is something to look at. Maybe this Waypoint project from HashiCorp, but I think Score is pretty cool, and it has, I think, 3,000. It has no 8,000. I don't know. Maybe somebody can look this up. I think this has 8,000 stars or something. Yeah, so we're going to look at this in just a second. So that's the developer control plane, and then we have actually the integration and delivery plane, and that's about you know, building the image, storing the image in the registry, dynamically creating the app and infrastructure configurations, and then actually executing things. And we're going to look at how this works in a second, because that's probably the component you're least familiar with. And again, this might feel like a little bit, oh, Kaspar talking about what he's working on, but you know, you can use whatever here as well. Then you have the resource plane, and the resource plane is, you know, in this case, Azure. We have the Azure Kubernetes Service, AKS. We have Azure SQL, Azure DNS, Service Bus. In that, you know, there's the sample resources. It can be whatever, right? But, you know, we're using those resources here as examples in those platform as code setups. Now then, monitoring and logging plane, where you monitor and log. That's pretty straightforward. And you have secrets and identity management. And secrets and identity management is Azure Key Vault. I'm outing myself. I personally prefer HashiCorp Vault, but I hope that's fair. On the security plane, there's actually more to it. So if you're in security heavy environments, there would also be things like, I guess, you know, policy checking mechanisms, Sentinel-1 and the likes, right? So that's on the security plane. All right, let's actually zoom in a little bit on the developer control plane, where again, you have the service catalog. And I think somebody asked about alternatives, and we can send a couple of over. I think I mentioned Port, Cortex, Campus by Atlassian. That's one. For some reason, nobody looks at this, but I think it's a really great architecture. And then we have the version control system. Now, the first thing that I want to look at is, what do we typically see in behavior of what people use in what situation? So the right horse for the right course, interface choice, right? And I have no data on this. This is really just a little bit of observation and gut feeling, and very possible that in 2 years somebody proves me wrong. But that's what I'm usually observing. So if you just deploy, you're not clicking in a UI, and you're just using terminal and IDE, right? In the vast majority of cases. If you do a change to configuration, you're adding an environment variable and all these things, then you would probably use a workload specification. We'll look at one in a second. Same thing if you're adding and removing resources. If you're doing rollbacks and different diffs, you can do the orchestrator API, CLI, or UI, or you build that functionality into the control plane, into the developer plane, where it's not actually, there's no standard integration. You really need to tweak something like Backstage a little bit. For configuring resources in detail, that probably remains infrastructure as code in the modern enterprise, just for disaster recovery purposes, spinning up a new environment, seeing logs and error messages, again, orchestrator, or you tweak the service catalog. It's in there, but it also depends. So Backstage has not that many plugins there, but if you're looking at if you are looking at something like Campus, again, feels like I'm advertising for Atlassian today, but no, they have actually like a number of really good plugins just for KPI analysis and all of these things. And then inner source use case, again, definitely portal or service catalog, and scaffolding use case probably as well. Cool. Now, what's a workload specification? Because that's an important thing. A workload specification, again, is a way for a developer to describe the relationship between workloads, other workloads, dependent resources, but in a way that doesn't care where it is. Does that make sense? So as a developer, I'm saying, hey, I have a Python service. I mean, it's ultra easy to learn. I like to describe it like you know, Docker Compose for a 3-year-old. Like in 20 minutes, you can totally master it. And this is such a file. It sits next to your service workload. It says, hey, my name is Python service. I have a resource dependency on a database of type Postgres, storage of type S3, DNS of type DNS. And we're not saying that particular SQL instance or whatever. No, we're just saying it in general, I need a Postgres, right? And then if we go ahead and as a developer, I want to run this locally, I do score compose and it will convert into Docker compose. And if I want to run this on, say, I don't know, in my development environment, I do git push, I'll send it through my pipeline, hits CI pipeline registry, the orchestrator looks at this and says, okay, well, I know how to create the configs. And I'll show you in a second how it's actually doing that. But this is an important piece here. And we're introducing that the standardization by design is possible because we have that slight abstraction, slight separation of concern. It's a golden path, remember? So, you can basically circumvent this and say, hey, whatever, I want to go down to the Terraform level. That's fair. But 80% of your developers, and I'm telling you, that's what they are going to use. And they are saying, oh, I appreciate that I could go low level, but I choose not to because I want to focus on service code. So if you look at this, you can ask, well, I mean, do we take context? No, and that's very important, right? You can abstract. You can never abstract at the expense of context. That's one of really our key learnings. If you say, hey, S3, there needs to be a dry run functionality. The user needs to know exactly where is the, let's say, Terraform that leads to the final configuration. What are the input factors that will be forwarded and all of that? That is very, very important. Integration delivery plane. We're going to look at this later. I'm going to skip this. I want to show you something. What happens if we do a git push? That's the easiest way, in my opinion, to actually learn how these things fit together. So if we do a git push, then with every single deployment, the score file will make its way to the CI pipeline. And after the CI pipeline, it will send the metadata to the orchestrator. And the orchestrator responds with an RMCD execution pattern, which stands for read, match, create, and deploy. And in the read phase, it will read the score file. In the match phase, it will say, hey, where are we? It will read the metadata and say, well, environment type equals staging. Okay, perfect. Let me figure out what the baseline configurations are that the platform team has provided. And then in the baseline configs, it will say, well, there is already a Postgres, just fetch the credentials and wire stuff up. Or it could say, we need a new one, and this is how to create it. And it will tell it how to create app configs and all of that. And then in the deploy phase, it will actually hand over, the orchestrator has CD capabilities, but it can also just hand over to something like Argo or Flux or Azure DevOps to then do that. It will orchestrate the infrastructure and off we go, and the application is deployed. Now, I want to follow a couple of golden paths that we can design with it. And 9 out of 10 platform engineers, if they talk about golden or think about golden paths, will always say, I don't know, it's the scaffolding of a new service in a portal. And that's, a nice start, but it assumes that this is enough to standardize. The reality is that your resource will be around for 1,000 days. And if you only standardize day one, it doesn't get far. It will drift between environments and labels and annotations change. And then you need to roll this out everywhere. And it's not super helpful. And so in this approach, because it's dynamic, we dynamically create everything. And that allows us to have a golden path with every single release. So let's go through an example. Super simple deployment to development. You can totally do this with just GitHub Actions. There's nothing special about this. From a developer's perspective, I'm taking my score file. I'm indicating the context development through the tags or whatever. It's the orchestrator. We do read, match, create, deploy, and everything is running. Now, this seems trivial, but it allows you to actually now say, okay, well, we're rolling out new baseline configs, we're changing some of the security settings, and it's a chance to clean up every single time. Let's take a little more special example, the golden path to create a new environment, which should be possible because we're dynamically creating, and the developer experience is incredibly elegant. You take the same file, just change the context to ephemeral, hits the orchestrator, read, match, create, deploy, and we create everything new wired up, and then off we go. Now, let's take an example for the platform engineer. You want to have want to upgrade Postgres from version 14 to 15. Today, you would message all your colleagues and say, hey, can you please do this, and then pray. In our world, you just say, hey, what resource definition of a Postgres, you might have, I don't know, 4 or 5 in the enterprise, does the service depend on? You just update the resource definition, you enforce a rollout throughout all dependent services, and then you have that done, and it should not be more than 5 minutes. Cool. And then we have one example going off the golden path. So what happens if you do something that the orchestrator doesn't know about, and that shouldn't be a frustrating experience either. The example here is you add a RangoDB, and the developer request is, I need a RangoDB, and that the developer, should they have the role-based access control, can add a resource definition that hits the orchestrator, a RangoDB is available, and the next time you do that, it is already there. And we call that standardization by design. And this actually brings me to an interesting point. In the end, platform engineering, good platform engineering, is about well-structured repositories. High degree of or rigid role-based access control on these things will lead to a high degree of standardization. Loose RBAC will lead to a low degree of standardization, and you have elements that are really developer-owned. Workload source code, specification, the pipeline YAML, if that's not central. And you have elements that are platform-owned. Resource definitions, infrastructure as code, baseline configs, workload profiles, automations, and compliance. And that also tells you how this platform can grow. A high degree, so you could go ahead and say, I have a developer that went off the golden path, but this should be actually available to the entire platform. And that means it's one pull request, and everything is, then it can actually be supported on a global level. Cool. I'll stop right there and see whether there are any questions.
Cool. Quick rundown, Kaspar. Not like the previous ones, but let's start from the first question. Can you please mention backstage alternatives again?
Sure. So yeah, and we can send them in the email. I would look at Compass by Atlassian, like the Compass, and I would look at LeanIX. I would look at Cortex, like the Cortex, and I would maybe look at Port.io. Yeah, I would say those are the. Remember, a portal is a user interface layer, right? It's not much more, not much less. It makes sense to look at this. Your job is not done if you have a fancy UI.
Cool. Did you consider broader application lifecycle management service like Azure ADO or GitLab?
Yeah. So yeah. So it's the strategy of GitLab to say that it can do everything. It can do a lot of things, but that doesn't mean it can do everything great. So I'm not a big fan of using GitLab everywhere. And second, it doesn't really solve that those principles. And third, I use GitLab all the time. So I will use in such a reference architecture CI with GitLab, for instance. Big fan of that. But it also does not really change the approach of the fact that usually the enterprise is multi-CI, you have several registries, it's multi-everything, right? And you want to make sure, and the world is, I think GitLab sales teams would love that, but the world is very rarely a single element.
I know it was just announced in the last 2 weeks, but I'm assuming some of your platform will change because of Microsoft Fabric.
I don't think I have enough experience on that tool yet to really comment.
Okay, let's move to the next one. How is identity managed? Is it AAD, OpenID, a custom IDP?
Open, yeah, Active Directory.
Okay. Do you handle also data migration as part of the platform, for example, when changing the database versions or rolling out while new environments?
Yeah, so that's a tricky bit, right? You can do that. So we have an element in the resource definition section that's called drivers, and you can put data migration tasks into that are triggered on the environment change. We're getting into the nitty-gritties here. That is possible. There's more to it, right? So for instance, if you're spinning something up, you probably want to have a environment with synthetic data. So how do you handle this? How do you preload this? You do that by in the create phase of the resource, letting a so-called resource graph sequence how these things get created. Another example would be, which I would recommend if you have the money. I would look at something like Ivan, which is a database as a service provider that's running on Azure, and they are fantastic of taking care of that. And they have a number of integrations in that platform world that makes it way easier to do these tasks.
Cool. How do you manage hybrid or multi-cloud systems? Is Azure architecture going to be a part of this platform?
Yeah, that's a great question. So, by default, if you have dynamic configuration management, the system can actually create the configurations based on the context, which means that in the end, it doesn't really matter where you're shipping stuff. And so that makes it perfect for the use in hybrid and multi-cloud environments, which is the case in, I actually saw the statistic last week, 17% of cases.
Can you expand on your point that if you have more than 50 developers, then reference architecture for IDP, like you proposed, makes sense? What do you suggest for teams of less than 50 developers, Terraform or other tools?
So if you have a small developer population, then you always need to ask yourself the question, do they really have the pain points? Why? You usually don't have that amount of maintenance. You only have a couple of people dealing with the teams from them, and you're probably fine, right? And there is a, I don't know, right? If you are less than 50 developers, don't overcomplicate things. Like these platforms, they need babysitters, right? And I think you can, there is a big risk if you're small to over-engineer things. I think you want to be a little scrappy and you want to be a little freestyle. And you can just use, I think you can just use Helm charts and Terraform files, and if there's a problem, you ask your colleague who's great at HCL, and life's good, right? I'm a little hesitant to over engineer these things. If you say hey, we're growing super fast, then you might want to consider this, right? But if you're not growing and things are stable, why make your life harder than it has to be?
Exactly. Hi, Luca. I think I remember you from somewhere. Would you mind going into more detail concerning managing state? If you consider every day as a day one, how do you manage state in your workload specification?
Yeah, because you don't, right? The state is really just the abstract state of the environment and not the final state. And but because you have the abstract state and the exact set of rules on how the actual final state is created, the final configurations are created, you have an immutable record of everything. But yeah, the answer is the state information is not in the workload file, but that doesn't really matter, right? Because you can recreate the state at any point in time.
And the last question, are you building Terraform modules for sharing with Terraform users?
That depends what you're asking. So if you're asking whether we have a set of perfect definitions for Postgres, the answer is no, because those things are incredibly hard to maintain. If the question is, do we have Terraform modules for those platform as code elements? Then yes, absolutely. That's actually what we're open sourcing. So the platform as code thing will be available for.
And the last question, can you elaborate what you mean by configurations?
If I speak about configuration, I mean two types of configuration. Number one, application configurations. In the, let's say, Kubernetes world, those would be manifests. If I speak about infrastructure configurations, I speak about infrastructure as code, Terraform, S3, Terraform, Boomi, Crossplane, and such.
Cool. I think that's a wrap for today. A very quick one this time. Thank you, Kaspar, for this crazy place you're having this webinar from. I think we need a post on social, different crazy places you ever led a webinar from. So we're making a selection of those. But guys, I just remembered we had a PlatformCon last week. If you haven't checked the videos, they're on our YouTube platform engineering channel. So start threads in the platform engineering Slack channel. If you have any questions to the speakers, you can still tag them if you have any questions. And I guess we'll let everyone to enjoy their evening. We'll send over the webinar slides and webinar replay tomorrow. So thank you so much to those who attended. Hope you have a great rest of the day.
All right, thank you very much. And my apologies for the unprofessional location.